Exciting, fascinating world of chemistry. We're beginning to look at acid bases. And in order to do acid bases, we're going to start with acid nomenclature. Now, the first type of acid nomenclature is binary, which only means two. The first element of any acid is always hydrogen, and then some non-metal, nitrogen, fluorine, carbon, bromine, anything along those lines. All right, so what we do is we take hydroic acid, the base word. So an example, if it was HCl, it'd be hydro, that's chloride, so it'd be chloric acid, and we get hydrochloric acid. Now, for eights, for the polyatomic eights, it's ic acid. So here we have the example HNO3. NO3 is nitrate. Take the 8 off and replace it with ic, and we get nitric acid. All right, last ones, ite acids. Ite acids are going to be us acids. So right here, ClO2 is chlorite. H out front identifies as an acid. So take the ite off and replace it with us, and it's chlorous acid. All right, so distinction between strong and weak acids. All right, for a strong acid, we're going to make an assumption. What that means is it dissociates 100%. What does that mean, dissociate? Dissociate means it breaks down into its base ions. It dissolves, it separates into its base ions. Now, a weak acid goes through equilibrium. So like chlorous acid, which is a weak acid, we're going to have both hydrogen ion, chloride ion, and the acid at the end of the day, where a strong acid like hydrochloric acid is 100% dissociated. We have no acid at the end, just the ions there. So how do we distinguish between strong and weak? Well, we're making an assumption that all binaries are strong. So if it's HCl, HF, HI, H2S, all those are going to be strong. For eights and ites, what we do is we take the number of oxygens, subtract the number of hydrogens. If that number is greater than or equal to 2, then it's strong. Less than 2, it's weak. So let's do the example H2SO4, which is sulfate, which means a sulfuric acid. All right, so we take number of oxygens 4 minus the number of hydrogens 2. That's equal to 2, so it's definitely greater than or equal to, so that's a strong acid. All right, let's do an example of H2CO3. CO3 is carbon 8, so that'd be an ic. So that's a carbonic acid. Carbonic acid, taking the number of oxygens 3 minus the number of hydrogens 2. That's less than 2, so therefore that's a weak acid. All right, so let's do these. We'll do these in class. HI, H3BO3, HiO2. We'll name them, identify the strong or weak, and then hydrosilanic acid, hydrofluoric acid, and carbonous acid. We'll do the formulas on those and identify strong as weak as well. All right, and then we'll do these in class as well. That's it. Take care. Be good. Any questions, let me know.